Hello, welcome to our senior design presentation. We are Rad Solutions and we will be presenting our leak test diagnostic system for shipping radioactive materials sponsored by Idaho National Labs. I am Easton Heaton. I am a mechanical engineering major and I will be going into nuclear propulsion after graduation.
Hello, my name is Ammon Black. I'm studying mechanical engineering and I'm interested in going into my graduate studies to study energy systems.
Hello, my name's David Foote. I'm a mechanical engineering student and I'm also a retired aircraft mechanic of more than 20 years. When I graduate Utah State, I plan on seeking employment in the aircraft industry in either advancing new technologies or sustaining aging aircraft. Thank you.
My name is John Odland. I'm a mechanical engineering student with an emphasis in aerospace engineering, and after graduation, I will be pursuing a career working with jet engines.
Idaho National Laboratory, or INL, has been tasked by the Department of Energy with the safe, secure recovery of radioactive isotopes from all around the United States. These radioactive isotopes are often used in hospitals for diagnosing and treating diseases. To safely recover these radioactive isotopes, INL prepares large casks, as pictured here, for transport. These casks are designed to ensure that no matter what happens in transit, radiation will be retained inside the cask. To ensure secure transit, INL is required to test a small annulus in the lid for leaks. The annulus, pictured here, is pressurized to 18 to 19 psi and is required to drop no more than 0.1 psi in 15 minutes. The problem faced by INL is a result of the nature of gases, in that when a gas cools, its pressure will decrease. INL refers to these decreasing pressures due to temperature changes as virtual leaks, since they behave similarly to a real leak, but are not indicative of a real leak. Our mission is to determine a virtual leak from a real leak, and otherwise improve the accuracy of INL's procedures using the ideal gas law. Our system must indicate leaks larger than 0.1 psi over 15 minutes. Our system must be portable and have an easily operable user interface, and our system must be able to function in an industrial setting.
Thank you, Ammon. I'm going to discuss our overall design, system operation, leak analysis, and storage. The hardware used in our system is not very complex. It's comprised of a housing assembly, fill valve, temperature sensor, pressure sensor, quick connect cables, data acquisition device, or DAC for short, industrial laptop computer, and an atmospheric pressure and temperature sensor. The more complex portion of our design lies within the algorithm, as I'll discuss next. The system algorithm works by measuring pressure and temperature of air contained within the cask annulus while concurrently measuring the atmospheric air pressure. The pressures and temperatures are monitored every second and used in a variation of the ideal gas law, which can be seen here. This equation calculates predicted annulus air pressure based on measured temperatures. It is also known as the allowable pressure and is used to determine if the system is leaking or not. For example, if the actual air pressure is measured below what the allowable air pressure predicts, then a leak caused the loss in air pressure. The system will fail for an actual leak when the annulus pressure decreases 0.1 psi and is less than the allowable pressure. When this occurs, the algorithm determines the pressure loss was caused by a leak source, and the leak check will immediately fail and the program will terminate. The system identifies a condition known as a virtual leak when the annulus pressure has decreased 0.1 psi and the system pressure is greater than or equal to the allowable pressure. In this case, the algorithm determines the pressure loss was caused by decreasing temperatures and the leak check will instantly fail. However, when this occurs, the leak check will automatically restart and the cycle will continue until the leak check either fails for an actual leak or passes the leak check. The leak check will pass when the system pressure does not decrease 0.1 psi in 15 minutes. The system is stored securely in an impact and water-resistant Pelican case, which can be seen here. This case protects the system components during shipping or when not in use.
This has been an overview of our leak diagnostic system. We want to give a special thanks to Kevin and Christopher from Idaho National Lab for sponsoring our project, and also Professor Graham for all the help he has provided. Thank you for watching.